right, friends. Good afternoon on a Sunday. टेस्ट मैच देखना बंद करो, मैथ्स पढ़ना चालू करो दोस्तों. टेस्ट मैच में कुछ नहीं रखा है, 4 विकेट गिर चुके हैं, हारने वाले हैं हम लोग. नहीं हारे, ये हमारी उम्मीद है, पर लग रहा है कि हम लोग थोड़ा हारने वाला है ऐसा. All right, friends, welcome to Simple Maths episode 2. I know how to count till 2, so we have reached till episode 2. Today we'll be learning some things that are great fun, and I wish they were taught better in school, but they were not. Okay, why am I talking with an accent? Because I'm nervous, slightly nervous. So today we're going to, I asked Karis what she wants to learn, and she said she wants to learn how to multiply faster in her head. So I have some kind of solution for that. So we'll learn that. Little bit of trigonometry we'll touch upon. Interest in trigonometry, no usage of sin theta cos theta, उसमें घुसेंगे नहीं हम लोग. थोड़ा trigonometry ऊपर ऊपर से बात करेंगे और थोड़ा calculus का बात करेंगे क्योंकि KV wants to learn a little bit about calculus and KV is here. So can we have both of our guests, Kanis and KV, on screen, please?
Hi. Hi, buddy.
Amazing.
Hello.
Hello. Hello.
Hello.
Hello, friends.
Hello. Thank you.
How are you feeling, Kanis? How are you feeling, KV?
I'm feeling good. I'm a little bit nervous to be learning maths on a stream, but I'm excited that I'm learning from you. So
I'm
Okay,
very excited,
awesome.
very excited.
But he's always excited.
But it's all
That's awesome. Tell us a little bit about how you were you good in? Sorry, I'll just stop this share. It's okay. I'll share it when necessary. Tell us a little bit about first KV. You tell us how was your maths experience in school? Were you good at it? Were you did you suck at it? What was the scene?
I was good at it. I was a good math student. I think I was really good till 7th, and till in 8th there was a dip, 8th, 9th. Remember the time when we started learning surds and some sort of some subjects which did not make sense at all. But then I picked up in
Right.
10th. So I was really good with trigonometry, mensuration, everything. 11th, 12th also while preparing for IIT. Maths was the only one out of the three, like PCM, that I was really good at and I really enjoyed doing it. Um,
Okay.
Including coordinate maths and like every except probably probability. But that brings me to today's topic, and because I was good at calculus, but and then that will become a rant about education system, so let's not go there. But I never really understood what we are doing. Like I could solve a
Correct.
question, I could solve an integration, differentiation, but till date, when you talk to me about this episode, I was like, I don't know what limit tends to zero means, or like why
Correct.
are we doing. I know like calculus has a lot of implication in science and engineering and technology and everywhere, but I don't know what we were
Correct.
doing. I still don't, and I'm looking forward to learn that from you today.
That's amazing. That's amazing. I hope I can give you a little satisfactory answer on that. Kanis, what's your scene? How was your maths in school? And
so my relationship with maths was I used to be decent at it, and then in grade like 9, I was like in first set maths, and then every subsequent year they kept dropping me a class down because I just kept getting worse and worse at maths, and I found like it was too much pressure, and I wasn't able to grasp the concepts at a first like a first section level. So it's really funny. I went from like first to second to third by the end of my like
wow.
high school. Yeah. So
Wow.
I definitely, yeah, it doesn't come very naturally to me to understand concepts, but I feel like
Okay.
if I work at it, I can grasp. Um, let's see.
Got
I
it.
don't. And it's been 20 years since I did anything related to maths. So
Yeah.
exactly 20 years this year. So
Awesome.
yeah.
Awesome. So I was never good at maths, but I'm good at explaining. So that's what I'll try to do.
Cool.
I will first start with the Kanis question, and can we switch to the yeah? Great. So Kanis wanted to know about multiplication. I don't have a pen, so I am writing with my finger.
Oh wow.
Okay, multiplication. Yeah, brother, this is
Exciting.
how I can write. Yeah, thanks. So, multiplication is mostly, we always have a calculator. And these days we don't really need to learn it, how to do it mentally, etc., etc. What I thought will be useful to learn is how to take a quick guess. right? When you're, say, bargaining a deal, or you're at a shop and you just need to calculate fast without taking
Yeah.
out a calculator, because there's no real way of doing it fast and accurately. So this tries to strike a balance, being fast and approximately in the range. Okay, it'll not be very accurate, but you'll find some kind of answer. And I have figured it out right now for only like something like 48 into 36. Okay, this you have to do mentally,
Hmm.
right? So two digit number into two digit number. So typically, what would you do? You would start with 6 into 8, 48, 8, 4, blah, 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 and then 6, 4, 2, 8, 8, right? This, then 3, 8, 1, 4, 4. Then you'll try to add it and get the answer, right?
Yeah.
Some
Yeah.
like, so this is the basic way we are taught in school. My method is slightly different, which is, say we take 48 into 36. Um, what is easier for us to calculate is if we find the big number first and then keep adding to that,
Yeah.
right? So if we just do 40 into 30,
Correct.
because it's 48 into 36 is essentially 40 into 30 plus 40 into 6,
Yeah.
right? Plus 30 into 8 plus 8 into 6.
856.
This 8, the thing is, this 8 into 6 is the most irrelevant in terms of accuracy because it's the smallest number,
Hmm.
right? If you by the end of it, if you get the first two, three digits correct, you'll be in the range. So here, if I just erase this and I try to do it mentally, 40 to 30 is
1200.
correct. So you know that the biggest number you have right now is 1200, right? Then we do 40 into 6. So it's just the way to remember it is 48, 36. So first you do this, then you do this, then you do this. Okay. So 1200 plus 240, which is 1440, that you can hold in your head. Now 3 into 8,
240.
that is 240 again. So 40 plus 2, 40. Now you know you're somewhere in the range of 1600, 1700.
Hmm.
And if you want, you can add 8 into 664 and find the exact answer. But very quickly, you can come to 1600, 1700,
Yeah.
right?
Yeah.
So we'll try another one and we'll try to do it with the paper and then we'll try some without the paper. I'm not trying to get the accurate exact multiplication,
Yeah.
this thing. Just trying to get a sense of where the number will lie. Because you will always have if you need to calculate accurately, you always have the calculator. There's no need to do this.
Yeah.
It's only when you're comparing two curtains, three curtains, or if you're buying a bunch of stuff in a heavy market and you don't really want to take out a calculator and you're comparing in two shops or like your curtain lengths versus blah blah blah,
Exactly.
then this is an easier way of just keeping hold of things, right? So we'll say do what is the number 57.
You know, a man is recently married when his examples involve curtains and whatever. Like the
Your
pre-marriage
brother.
people would never give curtains and two shops as an example.
Shop's curtain.
But most of my life is this only.
No, I
uh,
need this when I didn't have this when I was calculating my alimony.
Okay.
So, okay.
All right, friends. 56
Right.
into 57 into 66, let's say. I'll just check the chat, what the chat is saying, sound on, everything is okay. What is really maths, blah, blah. Okay, it's normal. We got some super chat. Bhai Shadi Mubarak. Okay, thanks. Thank you, Devans Jaju. You will be, you will also have had marriage, or you already have, I don't know. So 56 into 57 into 66. So what do you do first?
3000.
3000, right? So hold that 3000. Now you do either 5 into 6 or 6 into 7, one of those, whichever is easier for you. So 5 into 6, that's
Uh,
300,
420.
right?
So, sorry. And
Right. And now if you just want, so right now you know that you're somewhere around 3720.
Hmm.
If you want, you can add the 7 into 6, but I don't think you really need. Like, if
Okay.
you want, then you can get it. Um, but yeah, like you get to the range much faster,
Yeah.
uh,
Yes.
rather than jumping around trying to do 7 into 6 first or this thing. Okay, we'll try.
This way you get to the accurate answer very fast as well.
You can. It is a little harder doing mentally.
Yeah.
I mean, if you know your times table, then the last step is not like too
When we
difficult.
actually do it, by the time you get to the last two digits, you will have already three digits running in your head.
Got
So
it.
it
Got it.
becomes a little hard.
Got it.
That's why I don't want to stress on it. But obviously, if you practice, you'll become very good at it. So I'll try doing one mentally without writing down anything. Okay. Um I don't know why I like six. I don't want six. I want seven, two. Give me any other number.
98.
98. This is actually much easier than just, you don't even need to do this process because you can just do 7200 minus
Minus.
140.
Yeah.
So
Huh?
you just seven zeros. Yeah, some 7040, something it's like that. Because it's 72 into 100
Oh,
and
Minus.
then take out two 72s, right?
got it. Got it.
So it's very easy. It's
Got
that way.
it.
It's very easy. Once you get into 90s, it becomes very easy.
Okay.
So I'll take another number, 81, and give something else.
32.
Okay, 32. Let's do mentally and see how accurate we are. Both of you just do it mentally. Then I'll ask you the answer. Ready, guys?
Yeah, I think yeah.
Okay, tell me your answer, Kanis.
2862.
Okay, cool. KV, what is your answer?
Um, 256, 256 something like
Yeah,
25,
2
25.
5 is more in the range.
Yeah. Yeah.
So 2592 is the actual answer.
Okay.
Kanis, let's see what you did and which step you went wrong.
I went 2400 I got from 8 and
Yeah,
3.
yeah.
Then I got like 200 and I did 8 times 2 which is 160. So I went 200 and 2560. Then I
Yeah,
did 1 times 3 which I thought
30,
was 300. My bad.
300. Correct.
Yeah,
Okay,
yeah,
so
that's what
that's
I did.
the, yeah, right. So when the numbers are like once, if you do it couple of times,
Yeah.
then you'll realize the smaller numbers it will be 300, the larger numbers will go into hundreds. We'll try one more time and then move on to the next topic.
Oh, sorry, 1 second. Sorry. But so I got confused. Uh, sorry. If I did 8 times 2 was 160, then what is 1 times the 3?
That is 30.
30.
Yeah,
Oh, of course. Sorry.
yeah, right.
Yes, sorry. Got it. Okay, got it.
Yeah, exactly.
Okay.
So last one we'll take and then we'll move on from this. So I hope you had a useful skill from this. Let's try to do it mentally. I'll also try. Got it, Kanis?
Yeah.
Okay, cool. Tell me your answer.
2385 237.
That's my answer as well. That's KV's answer also, I am
Yeah.
assuming.
Yeah. 238.
Let's see. 53 into 45 equals 2385.
Yeah.
It's indeed correct. So you see, with like if you practice it for a day,
Yeah.
then you'll get to it very fast,
Yeah.
and you don't need to be confused with this. And then obviously, three-digit numbers, etc., etc., etc. We can see later. I don't think those are like if a three-digit number needs to multiply by a two-digit number, then the simplest thing to do is like, say you have to do 129 into 56, right? Then the simplest thing to do is to convert this to 130, 13 into 56, because you're trying to get an approximate answer, right?
Yeah.
Kanis?
Yeah, sorry. Sorry, the sound went. I'm so sorry, I'm here. Okay.
No problem. Okay, I'll
129?
just,
Yes, please. Yes,
so I'll
please.
tell you the approximate method of doing this is 129 into 56, say you're trying to do, right?
Yep.
Kanis, can you hear me?
Yeah. Sorry, I'm here. I'm here.
Yeah,
129 times 56.
you can just 13 into 56, right?
Got it.
And then multiply the answer by 10. And you know that you're in the range,
Yeah.
right? You don't need to multiply three digits by three. So, I mean, if you want to get accurate answers, then obviously use calculators. This is for just uh, good guesses, good
Yeah.
guesstimates.
Yeah.
Great.
Which is,
Okay.
we joke about the curtain thing, but
Yeah.
that is where measurements come out, like when I'm trying to calculate like
Yeah.
centimeters and etc. This is
Yeah.
helpful.
Yeah.
Yeah.
Anything
Square
else has
feet,
come
centimeters.
in? Just check the chat. Besa running cat con class. Nice. Blah blah blah. People are doing a good chat. Keep doing more maths.
Ah,
People are giving us 420 into 69 to calculate.
Nice.
Very nice, brothers. Okay,
One thing
chat is
that
always
I
here.
just to add one small point, Biswa, and to Kanis,
Yeah.
one thing that I always invariably do is something very similar to this, is where in my
Hmm.
mind I just round off to the closest thing. For example, when he said 420 into 69, in my mind I'll just multiply
70.
420 by 70.
Hmm.
Correct.
And I'll, because those are always easier multiplications, right?
Yeah.
It's 134 into 67 or something. I'll round it off to the closest one. Like 67 in my mind is 70,
Yeah.
and 124 is 120. And then I'll just multiply 12 into 7. And then I know that, like, add couple of zeros after 120 into 7, and I know that answer will be somewhere there.
Yeah.
Correct.
So some approximate idea I'll have.
Yeah.
It's always easier to multiply into 10, and then maybe if it's into, like, if the last digit is 5, you know in your mind just divide by 2. So things like that always help me personally.
Hmm.
Yeah. That's awesome. Okay, so that's a useful skill. Okay. Now we go on to trigonometry.
Oh, we're done with multiplication. What about
That's it.
di- what about division? Another stream.
Division, again, it's not easy to do
Yeah.
mentally. The simplest thing to do is if you have to multiply by 25, sorry, if you have to divide by 4, then just multiply by 25,
Got it.
right? So something like that. You have to find division is not easy to do
Oh,
mentally.
well, okay. And it's another stream.
Yeah, I'll try and find a method that makes it easy,
Okay.
but it's not going to be as easy as simplifying multiplication.
Yeah. Fair.
It requires a little more memory, and you need to know certain divisions, and then you need to approximate.
Yeah.
See, guys, it's easier to build and multiply than divide.
It's true, but in practice it's otherwise. Okay. Okay, so trigonometry, I just want to give a simple intro to trigonometry. I don't want to get into the exact, like, a lot of details of what is sine theta, what is cos theta. So trigonometry basically comes from the word tri, because it deals with everything with triangles,
Triangles.
right? So, and why are triangles important? Because they are the simplest geometric shape, and using just triangles, you can calculate so much, right? The simplest example why people started doing trigonometry was
Yeah.
because,
Why? My
yeah,
biggest question.
because you can measure the height of, um, if you know what is this angle, you can measure the distance of this tree with just a pen. So you put a pen here, you know this angle, and you know this, so you
Oh,
can measure the distance of a
wow.
tree, right?
Yeah.
Oh,
So that
yeah, I've never
so
seen it
when
explained like that before. It's so
yeah,
simple.
it's simple, right? And you can this is very useful while they're constructing houses. um, because you can just, you know, through the angles, you can make sure that you're not constructing wrong and stuff. But what I want to talk about today is how useful, um, trigonometry can really be. Is that you guys all know this, right? If you put your thumb in front of your eyes, just do this. When you close your left eye, the thumb seems to be at one place. Now you close your right eye, the thumb seems to have moved,
Yeah.
right? It
Yeah.
moves slightly. Now put your other thumb behind it. Now you do the same thing. Close your right eye, the thumb moves. Close your left eye, the thumb moves. But the thumb that is far from you moves less, and the thumb that is close to you moves more,
Yes.
right?
Yeah.
So this is called parallax. Okay, this right. This is why humans can perceive depth, because you have two eyes, and both the eyes are always working to give you that this is closer to us, that is farther than us. If you're just one eye, you won't be able to perceive uh, depth.
Like my new
Okay.
camera is doing that for us, creating depth,
Yes.
making us
Yeah,
perceive
but
two parallel.
your camera does it by giving focus and focus. Somebody has given 100 rupees tuition fee. Thanks, Avinash Thakur. Thank you so much. So this is called parallax, and in a way, the 3D movies use this to trick your brain because the screen is 2D, but both of your eyes are being fed two different images. Okay, so earlier it used to be red and
Agree.
blue. So you'll get one image here, other image here, then your brain juxtaposes it, right? Right now you get Polaroid glasses. So one is getting the light polarized like this, other is getting the light polarized like this. And the same thing, like you saw with the thumb, how you perceive the distance, the same thing happens in your brain. Why is this interesting? Is because this is your these are your two eyes, and this is your thumb, okay, and this is a triangle, right, and this is your other thumb, and this is another triangle. So this simple thing comes under trigonometry,
Mm.
right? And because of trigonometry, you are just by using this principle, you can measure the distance between stars.
Mm.
Okay, so what earlier people did was say, this is the path of the Earth. Okay, Earth goes like this. It's here in January. It's here in June or something. Okay, here in December. Here in June. So these are like your two eyes. Okay, this the sun is here. Whatever. And there's a star here,
Mm.
and there's a star here. Okay, and there are multiple stars here, here, here. We are interested in this star, and there are multiple stars behind it also. So when you see it in December, you will see that this star looks like it's here, and the other stars are here. Okay, similarly, like your thumb you're seeing,
Mhm.
but when you see it in June, it looks like the star is here, and the other stars are here, because the stars that are behind are moving less, and the
Mm.
star that is in the front, so the star that is behind, like the thumb that is behind, is moving less.
Hmm.
The thumb that is in front is moving more,
Hmm.
right?
Yeah.
So by measuring in December where the star is, and measuring in June where the star is, they could figure out how far this star is the same one, is from Earth. This they could do
Oh.
thousands of years ago.
Yeah.
And it's just because this forms a triangle. This forms a right, and this also forms a triangle. So that is how useful trigonometry is. I
Yeah.
have gotten a new super chat. Let me check. So please make a regular video like this. I'm preparing for NIM set. Okay, friend. I will. आपका नाम क्या है? Econ 22. Great.
Yeah. Like the first example I thought of, Kanis, when Biswa told that building thing
Hmm.
is and you'll love this example, is because, for example, when humans we saw Mount Everest, okay, and you want to know the height of Mount Everest, you don't
Yeah.
necessarily have
Want
to
to
see
climb
it
it.
to an inch or climb it. You just use basic principle of trigonometry to find the height of Mount Everest, and
Yeah,
it's beautiful. Like you know that the height is 848 meter without climbing it or
right.
without actually measuring it. You just
Yeah. In fact, when they measured it, they found it to be exactly 25,000 feet. So they thought nobody will believe it, so they added 2 feet to it.
Oh, really?
Yeah. So the joke is that the guy who first measured Mount Everest put 2 feet on it the first.
All right.
Like that's the joke because he put 2 feet. Anyway, so you see how just by using triangle we can do so much. Of course, you need a telescope, but you can do so much calculations like how far the star is, etc. And a more like current example would be like when you're following Google Maps, the location of the so this is you, okay, and these are three satellites, and these three satellites communicate with each other to pinpoint your location
Okay.
for GPS, right? Only one satellite can't do it properly.
Okay.
So it's called triangulation. This is a method of finding. If you know this distance, this distance, this distance, then you can figure out where the person is, right? Very accurately. So this is again like while you're driving, you're not realizing, but this is your just basic triangles are able to do it. So that's it. I don't want to get into sine theta, cos theta, blah blah. Just one more example is when you're like you must have seen those graphs, no, of sine theta going like this,
Mhm.
and cos theta going like this, right? That is, you can imagine it as when you're cycling, your pedal is there, right? And when one pedal is up, the other pedal is down. So although they are going in circles, they are also forming this pattern, right? And that is the relationship between sine theta and cos theta. So you can just remember like it's two pedals of your bicycle when it's moving at a constant speed.
Got
So
it.
yeah, uh, cool. What a chat
Were the
say?
were the astrologers from back in the day? Were those measurements correct? The distance of the
Yeah,
star?
they're pretty accurate. I
Oh,
mean, pretty close.
yeah.
The amazing thing is that they could, you know, yeah, my cos theta is wrong. I'm sorry, guys. It is wrong. It's actually, it should be like this. It's slightly wrong. Um, maybe my sine cos is wrong. Then I'll check in the next episode and tell you. So, yeah.
Okay.
Next, I will come to calculus, which is again, like we'll go over very simply, not exactly getting into why, what is differentiation, like dy by dx, blah, 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 blah. Why does calculus exist, right? Why does it exist? Why do we need to learn it? Or what is the point of it? So, we regular human beings going through our lives don't need calculus. Okay. If you are dealing with any sort of machinery or any sort of moving parts that need to be accurate, like you're building a watch or something, then you need calculus. Okay. That is why calculus was invented very late.
Mm.
Uh, it is calculus. So, one way of looking at it is calculus is a tool that gives you access to more maths. What happens is, say we are just dealing with discrete numbers 1, 2, 3, 4, 5, then we don't need calculus,
Yeah.
everything is okay. But there are sometimes we need to deal with say the heat of the refrigerator, and it's like it's going like this, the graph you find, it's
Hmm.
a continuous quantity.
Hmm.
So it becomes very hard. Say your refrigerator, the amount of heat it's spending is like is this much. Like the heat is this much. If you just find the area underneath, you'll find how much energy it has spent.
Oh,
It's very difficult to do using normal methods.
Hmm. Hmm.
So this
right.
is why you need calculus,
Hmm.
right? When you get into extremely continuous quantities,
Hmm.
Okay.
right?
Yeah.
And most of the quantities in our life tend to be continuous and not discrete. The man-made things will be discrete quantities like money or number of chairs you have in your house, etc. will be discrete quantities.
mm,
But when you're driving on the road, it's a continuous quantity. Time is continuously moving, right?
Right.
And you are like most of the things exist in a continuum. Like say your heartbeat also discrete, but it is sort of more continuous than discrete, in the
mm.
sense that your heart is not like it's between the compression and the release. It's still in some sort of state, right?
Correct.
It's, you say heartbeat to 92 bpm, but something is happening in the middle.
Yeah.
So there are a lot of continuous quantities that people wanted to study.
Mm,
So it's a very easy example. Let's say, without going into continuous quantities, first discrete quantities. Say this year you earn 10 rupees, next year you earn 20 rupees, the next year you earn 30 rupees, the next year you earn 40, 50 rupees. Okay. So if I ask you, what is your change in money per year, like what is your change in income per year, then what did you say?
10.
10.
10, right?
Mm,
Right? So that's it. The delta money per delta year is 10. It's very simple. So remember just this thing, that this, I'll just write it here, delta money per delta year equals 10. Okay.
mm.
So that we have agreed upon that.
Yeah.
And if I ask you how much money have you totally made over these 5 years, then you'll just add them, right? Either 10, what is it?
150.
Wow, you're quick. You have been calculating that for a while, right?
No, I didn't
So,
know. I was thinking about the percentage growth, but that was something else. Okay.
yeah. So I'll just write this symbol here. I don't know if that is correct. I remember that sigma used to be this. But that means that basically I added all the money, it's 150. Now, this thing we did for discrete quantities. If money was a continuous quantity, if you are always like at every given point in time, you're getting some point 0.1 money, point 0.2 money, point 0.3 money, then the same thing would become different. Right? I'll show you a graph right here. So to it, so this
And does
is,
does Ambani make continuous money?
no,
Is that
nobody can make continuous money because it's a discrete quantity, right? So this is years, and first year you made 10, second year you made 20, third year you made 30, fourth year you made 50, whatever. Sorry, like you get it, right? This, but I have just drawn a graph. But you have not made anything in half the year, right? Like you
yeah.
get what I'm saying? You per
Yeah.
year you're making here. But if I were able to give you money in a continuous way for every moment in time, I was able to give you money,
Mhm.
right? Say per day I'm giving you 1 paisa, not even that. Like per nanosecond I'm giving you 1 paisa.
Okay.
Okay, and these type of equations come a lot. For say when you're driving, your fuel input is continuous into the tank.
Mm,
It's not like you're giving discrete, right?
mm,
So think about, say,
Sorry, Mister, but like discrete quantities, like over a period of time, can seem like continuous quantities, right? Like,
they can,
yeah, like
if
over a
you,
very long period of time.
correct, correct. But here we are dealing with more sort of, let's move on from the money example,
Okay. Yeah.
and let's say the fuel in your car, like how much you're putting. So it goes something like you started your car and it goes like this.
Hmm.
Now, if I want to know, I get this data from your car.
Yeah.
Okay. Now I want to know by this time. So this is time. This is fuel. Okay. So you're using this. I want to know after 1 hour how much fuel you had burned.
Hmm. Okay.
Then I need to know the area of this, right?
Got it.
And then I can figure it out. or I want to know, sorry, or sorry, one second, or I want to know at a particular point of time, at this point of time, uh, how much, uh, like what is the change in fuel? Because maybe you did something here,
Okay.
right? Your speed went beyond 30 or something. Then at this point, how did the fuel ka, um, sorry, fuel burning rate change? I want to know, say, if you burn fuel like
Yeah.
this, I want to know at this point, how did it change at this point?
Oh, right. Okay. Okay.
So then I use differentiation to find the rate of change, like we're doing this m by y, right? We're doing to find the rate of change of income. Uh,
Yeah.
Similar, and we're doing this to find out how much we have totally done. So this becomes dm by dy when the quantities become continuous and the instance becomes close to instant, right? I want to find at this exact instant. That is what
Mhm.
limit 10 something tends to zero means. It means that at that exact instant,
Mhm.
Oh,
right? At
Got
that exact instant, how much fuel you're burning. At that
it.
exact instant, how was your fuel consumption changing? That's
Mhm.
all it means. And then, obviously, then you can extrapolate this to you,
the
like
whole thing.
do anything in your life. But that's what it means. Like if you randomly get a curve from a machine and it's like this,
Mm.
then you want to know something at this point. Then at this point, the rate of change is this. We know that. At this point, the rate of change is this. We know that. At this point, the rate of change is this. So to from point to
Hmm.
point, whatever you input, you will find the dy by dx,
Correct.
Got it.
right?
Understood.
And yeah, and this is the integral of it. So that's mostly that's mota moti, like the area under the curve is always the integral,
Got it.
and the how the curve is bending is the differential. So that's all we need to know for now.
Okay.
Okay, too many super chats
Amazing.
have come. Thank you for these knowledge sessions. Admire work. KV, you're just awesome. ये बोल रहे हैं CA Pritpal. Okay. No, I think it's in Canadian dollars or something. Okay, cool.
Nice.
सर मेरा ट्यूशन फी नींद नहीं आएगा अब ये सब फ्री में सीखा तो आफ्टर ऑल द मनी आई स्पेंड ऑन स्कूल 10-15 साल पहले लव दिस सीरीज most of my most favorite people are taking my most favorite subject interesting. Bisa, thanks for this initiative. And Bisa, thank you for math stream. Would love to join this stream or collaborate behind the scenes. Regardless, stay awesome, keep going, says Rohan's tag there. Thank you so much. All right, friends, I think today we have learned enough. Don't need to learn any more. Then we'll become too knowledgeable. And
No, but Mr. Thanks for this calculus, explaining calculus a little bit. I'm not sure I ever understood it in my life. So, even though it was a very basic description of why we need to use it, it was really
yeah,
helpful. So, thank you.
Yeah,
no
the problem,
problem,
like
no
he
problem.
said, the problem is we'll all learn in our textbooks. Ki,
Yeah.
if you find an integration question with this, you have to do this.
Yeah.
If you
Yeah,
find a dy by dx of this, you put this. You never really figure out this thing of discrete quantity or continuous
Or that you
quantity.
can measure like the energy, that's not easy, that you can't easily measure.
Yeah,
correct.
Otherwise, you can use calculus to measure continuous, I didn't even exactly continuous quantities. That
Yeah,
makes sense.
yeah.
So
There's
it's,
calculus
it's
come.
difficult to measure continuous quantities otherwise.
yeah,
Correct.
maths becomes
Unless you're
beautiful when
making a note every millisecond, if you're making a note, like which you can't. So
like maths becomes beautiful when you can visualize any aspect of maths, right? Like when you talk about trigonometry being used in elliptical objects and solar system and planet, it suddenly becomes very fascinating
yeah,
compared to just learning that sine equal to 1 by cosine and
correct.
stuff like that. Okay, if the reason I ask you about calculus is also because at least in most of the other su- uh, subjects or in the sense chapters, there is some, even the questions had some sort of a visualization. For example, uh, the length of a field is this, the width is this, what is the area, so you can at
Yeah,
least visualize. Or maybe there's a horse tied at the corner and it's grazing or whatever. Okay, but calculus never had any question with any sort of, it was just,
image.
just x y numbers symbols. And that is why calculus became so daunting and so scary for most students.
Yeah.
You know,
Uh, Sorry, you said.
no, I was saying, for me, like, like visual aids help me understand and remember a lot more. Like I need to be able to see things to be able to conceptualize them, to understand them, and for my brain to like comprehend it. So
Yeah.
like when you
Yeah.
made all these images, I can learn. That's how I learn easier when it's in a picture form.
Yeah.
So
Yeah.
all these pictures like help me to understand these concepts.
Yeah.
All these images.
Also, I would just like to add that maths um, exists on its own in the universe, right? It's the rules are all there.
Yeah.
It's already there. We don't. What we do is we find methods to study it.
Hmm.
So initially we started counting one, two, three, four, five, six because we needed to keep count of our apples or sheep or whatever. Which is why it's very easy to visualize five cats, but slightly more difficult to visualize 15 cats, and it's way more difficult to visualize 47 cats
Yeah.
because your brain didn't evolve to count 47 cats because you didn't have 47 sheep or whatever, right?
Mm-hmm.
When it goes to 47, you use other things like herds or something to keep count of it, right?
Okay.
Dozen, you do dozen so that you can keep count of something, something, something. Then you invented minus numbers and fractions for financial calculations. Like if you owe me 10 rupees, then you have minus 10 rupees. That's a way of representing it. It was
Yeah.
always there in the universe. These numbers are always there. We just got access to that. Then we invented trigonometry because we needed to build stuff and we needed, to build simple tools, you need trigonometry. Then, much later, like 300, 400 years ago, people reached a point in maths where they were trying to go beyond um, what is like Newton was trying to invent stuff like the cube root of an equation. It's not easy to do, right? So because he wanted to solve problems that are more advanced than anybody before him had solved, he invented calculus along with another guy who invented it independently. He invented this method to study in much more detail. Just like the guys invented counting one, two, three, four, five, six,
Yeah.
he just invented calculus. Him and another guy, I think Laplace or somebody, they both came up with this. It's just a method. Again, it's nothing like it is, of course, abstract when you don't learn it in context, but it's just a method that is useful for slightly advanced maths, slightly advanced like life. That's it. There's nothing much. How much energy is your computer taking, or how much electricity you're using? All this can be figured out by calculus. That's the point.
Is math, is the subject of math just humans basically trying to figure out formulas to calculate quantities of things
Yeah.
or a distance or whatever? Is it just us looking for better formulas and easier formulas?
Yeah, it's tool making
Yeah.
for understanding, mostly for tool making. You'll really need maths because maths complies by some rules. The sum of three angles will always be 180 degrees in a triangle. The ratio of a circle to its diameter, like diameter versus periphery, will be pi. All these formulas really help us build the world around us,
And do we
right?
feed these, are computers built on these formulas?
Yes, of course.
Okay. Okay.
Of
So
course,
they,
like
they've been
everything.
inputted into computers. I know
Correct.
I sound really stupid right now, but like,
No,
is
no,
that
no.
how computers work?
Yeah, yeah, yeah. When you're turning right on your car, there is, without even going into calculator, your wheels have to turn in a certain way for you to take a curve, right?
Okay.
And that ratio has to be maintained. It's called a differential drive. I'm not sure if it's if related to differentiation or not. So
Okay.
it's everywhere around you. The very basic simple maths is everywhere around you. So yeah,
Cool.
cool
Cool.
friends.
Thank you,
Hopefully
Vikram.
you guys enjoyed.
Yes, thank you.
Really.
I mean, yeah, I'd love to do more with you. Please call me whenever. This is really helpful.
Okay, awesome. Awesome.
Yeah.
Same.
KV,
Same, buddy. Same. Anytime.
cool, cool,
Anytime.
cool.
Yeah.
We can end the stream now, Jen. Thank you, guys. Thank you, chat, for being there. I'll just see if there is any more super chats that I'm missing. No more super chats. Thank you so much. We can end the stream. You guys can be on the Zoom call, though.